Good afternoon, everyone. Brief introductions. I'm Polly Stanas. I'm a solution architect for our company, Public Cloud Group. We are a pure cloud-based consultancy company, meaning that we deploy infrastructure to the cloud and we create cloud applications. Today, though, we're going to talk about the edge and counter to what you might have expected, actually show a solution that is not cloud-dependent, but it is cloud-enabled mostly. Previous year we have discussed with maritime operations, with industries that have, as we call, on-the-edge requirements. And a topic that quickly arises is that how can we bring the AI, agentic AI with LLMs on the floor? Instead of having to log into the internet, gain access to a platform, how can we have the same benefits within our site? And in this specific case, we're talking about maritime within the ship. If you have to have an issue with your data, you have to do some maintenance or anything, you have to be able to wait for assistance, you have to do that on business hours, and you have to essentially be logged into having connectivity. We know, of course, right now that with current Starlink implementation and better internet, that is always a better infrastructure available, but still, we assume that the ship is an offline asset, and we want to enable it and treat it like that. So, edge AI, but local intelligence, what do we mean? It means that you have data on your ship. You're collecting massive and massive amounts of data from your IoT sensors, from any other operations. Why not be able to use natural language to extract information from the data on the ship? We can be talking about operational manuals. In our case, it started with the IoT sensors. There was a client on us that said, I want to collect everything that my ship emits in terms of IoT. I want to be centrally collected into the ship and give me an interface that my people using natural language should be able to get immediate information instead of waiting for those data to be synced online and then through a dashboard online be able to do that. Of course, we're talking about one of the most demanding industries. We have security and compliance. Data is the most important commodity in every industry, but especially for regulated industries. Operational continuity, zero dependency on connectivity. That is, again, we might be a cloud company, but this solution, it doesn't require you to have an ongoing cloud connectivity. We will see later on that you can send, how do you manage it and collect the information centrally within the cloud, but for you to operate it, you don't need an internet access. And let's go to the actual solution. So first and foremost, we're talking about running large language models. That requires special hardware on the ship. Currently, one of the best offerings is, of course, NVIDIA's Jetson platform. These are ready-made with GPU-enabled motherboards that you can install into a ruggedized PC with the industrial specification that the maritime and other industries require, and install it into the ship. Then, you can connect it with your operational network, collect all the information, and then be able to run large language models into Jetson with our custom interface that gives you access to those models in the form of an agentic interface. And this is the cloud part. So how do we do that? So we, as PCG, are a premier cloud partner of AWS. This solution essentially requires an AWS infrastructure for the sole management of managing your fleet. So that means that local installation with our solution and the LLMs can be centrally managed through AWS. So whenever you want to push an update, you don't wait for someone to go into the ship, install the new version or anything like that. Once it has internet, it will immediately download the latest version of the LLM, any other information that you want to install on that, and you will be able to have a central managed interface through AWS, but also centralized data collection. So that means that yes, we have the local platform, we run the data and we analyze them locally in the ship, but at the same time, we're collecting all the information into a central data repository within AWS to leverage the data analytics tools that it gives you. So let's see some scenarios and some use cases. We have here, of course, one of the most spoken out of with AI, like fuel consumption and any type of road optimization. So currently, you have to essentially, previously you would have to do this in a traditional way, be able to have communication, and discuss with someone to give you the proper operational values, and then be able to proceed with your journey. Having an LLM, an intelligent custom-made LLM for you on the ship, gives you and analyzes the information instantly, so you can use those parameters to adjust your information as needed. So, as we can see, the difference is light and day in terms of quick decision making. Another scenario is, of course, manufacturing control. On an industrial floor, right now we are talking about digital twins. We are able essentially to replicate having all the data collected from an industrial line and be able to visualize this and simulate it with something called digital twins. The same data that you can collect from your digital twin can be added into the LLM platform on the edge with a PC that someone on the industrial floor or on the management be able to immediately have access to the data. So we're talking about edge AI here having access to years and years of information, but live local information as well. So you'll be able to analyze your production line, make adjustments, and make informed decisions. And what else? Document processing. You might have heard it as a RAG or retrieval augmented generation. There are a couple of ways to do that. In our case, as with everything else, we're talking about analyzing operational manuals on a ship or any other industrial level setup. So you will be able to give an interface to your operators on the floor, be able to access that information just by typing some natural language, asking for an operation manual, and instead of having to go through PDFs or a shared NFS folder that the internet is down and it's not working right now, that knowledge is embedded within the model and they can access it, but also get a reference to the actual manual or anything else they might need. So, how do we do that, and what's the process to be able to enroll to the platform? In most cases, if we're talking about Maritime, we start with a single ship. We analyze the information, we discuss with the client. We do a feasibility study to see what's required for the local installation. Then we discuss about the data and start doing the AI training. And of course, we're talking about also doing crew training on how to use the tool. That will be phase one. Phase two is, of course, then to validate the data, get feedback from the customer, and see what potentially we have to change, what other information we might need to add to make the model better. So we do this refinement step, and of course, validate the cost and having a cost analysis. These are expensive tools, as you can understand. We're talking about model training, but still, it can be trimmed down only to the exact data you need. And then, of course, we go to the final stage, which is the fleet rollout, and this is where the centralized management we discussed before comes in. Once we have deployed the model, we train the model, the deployment to the rest of the fleet is just a matter of installing the edge device, having internet, and then the centralized management from AWS will be able to deploy to all those ships simultaneously the same version, the exact documents, and the exact model. So that means when a new version of the model comes in, all you have to do is push an update, and on the first connectivity the ship has or any other edge device, it will immediately download the latest data. So you don't have to worry about any data inconsistencies or different versions on different ships or edge locations. So, what do we need from the client on that end? First of all, industrial level devices. We don't provide the hardware. We can consult you how to procure it and what you need to do. We give you the specification, but you can decide on the hardware. We mention NVIDIA because we've seen very, very good results, but it's not a requirement. It can be any device that you can enable with a powerful enough GPU based on the inference requirements so you can run your data. Next is integration. Most of the ships on top of them, they have already existing tools. It can be a domain controller, it can be anything required for the ship's manual. We have to do the integration, and we as a company take that with our team to do that. And of course, we already discussed about our previous topic, cybersecurity, very important. We make sure to integrate with your current cybersecurity framework and never, never follow what your existing rule set is. Then it's training. So training is interesting because essentially all you have to say is that, look, instead of going into these folders or trying to collect this information, we give you a very familiar ChatGPT-like interface, as we've seen with agents and so on, and you're able to use natural language to access the information. That can be also used to generate artifacts. It can be used to generate reporting. It can be used to generate PDFs or any other thing you might need based on those IoT data or other information you might collect. The AI response validation protocol, give you some idea, is that at any given point, the current model that is trained is being tested against predefined questions and answers, so we make sure there is no information drift. If we notice that we started to get degradation in our responses, there is an alert coming to us and we immediately notify the stakeholder that we might have to do an update on the LLM or look into exactly what is that causing the degradation. Again, governance, maritime is one of the most difficult industries to share data. We have managed to somehow soft them into that, and they're starting being more open in sharing information, again, with a very strict framework, as we discussed. But essentially, the more data you can collect, the more information we can collect, we can make the model better. So we have proven that, we've shown them that, so they're more open to start doing that. And essentially, it is a matter also of not only giving us information, but giving us the ability to doing, as we say, the knowledge-based maintenance, which means, again, that data might be changing constantly, operation manuals might be changing, creating a data lake once isn't enough, or a knowledge base once isn't enough. You have to have a pipeline to always make sure you update that information. So we set up that pipeline with any current data lake or data warehouse or any other data solutions you might have to continuously feed the knowledge base with that information. And of course, we provide the dashboards for performance monitoring and cost analysis for that. So, what you can do to reach out to us as next steps, reach out to us on our booth. We're more than happy to discuss with you current use cases we have or how you can leverage the platform. Although most of our examples about maritime, essentially this can be applied to any situation that you need local AI, you need local LLMs on a tough environment or a more restricted environment, on cases where internet is not a given, or any case that speed and data access is very important. I don't know if we have any questions. So, thank you very much.